Hello students, I hope all of you are doing well, your preparations are going fine. So in this video we will be discussing PYQs of Electromagnetic Induction EMI chapter, right? Let us start. So the first question we have is the magnetic energy stored in an inductor of inductance 4 microhenry carrying a current of 2 ampere is. What is our relation for magnetic energy in an inductor? Let's say our inductor is there, inductance L and current flowing through it is I. Magnetic energy is given as half Li square, right? This is our relation, half Li square energy in an inductor. Your L value is given 4 microhenry and current is 2 ampere. So let's substitute 1 by 2 into 4 into 10 power minus 6 into I square. 2 square 4. So we get over here 8 into 10 power minus 6. So this becomes your 8 microjoule. 8 microjoule. Check your option. Option is option number C. Option number C is our correct answer. Yeah. So our question number 2, that is 22 question. 2022 question. Let us see. It says the magnetic flux linked to a circular coil of radius r is phi is equals to 2t cube plus 4t square plus 2t plus 5 is, okay, this is your magnetic flux given to you. It says the magnitude of induced EMF in the coil at t equals to 5 seconds. So EMF at t equals to 5 seconds. What is our relation? EMF induced we get it from your Faraday's law, and the relation is E is equals to minus d phi by dt, right? They are asking us magnitude only, so we need to find only d phi by dt at t equals to 5. Let us do d phi by dt. If we differentiate this, it will come out to be your 6t square plus 8t plus 2. Now if we substitute t equals to 5, E value will be, this is magnitude obviously, so this is 6 into 5 square 25 plus 8 into 5 plus 2, that becomes your 25, 6 is 150 plus 8, 5, 40 plus 2, which gives us 192 volt. 192 volt. So 192 volt is our answer. Now this is our relation, Faraday's law. Chalo, 192 volt, option number A, right? Question 3, again 22 question. It says a square loop of side 1 meter and resistance 1 ohm is placed in a magnetic field of 0.5 Tesla. Okay, side is 1 meter, resistance is 1 ohm, magnetic field is 0.5 Tesla. Fine. If the plane of the loop is perpendicular to the direction of magnetic field, the magnetic flux through the loop is, okay. So let's say that magnetic field is inward, right? They have not given any specific direction, they just said that plane of the loop, the plane of this square loop is perpendicular to the direction of magnetic field. So if plane we consider in xy plane, this is in inward direction, right? So they are asking us magnetic flux. What is a magnetic flux relation? So phi is equals to BA cos theta, B value 0.5, area will be, if side is 1 meter, area will be 1 square cos theta. Now as you can see, area vector will be inward, magnetic field is inward. That means area vector and your magnetic field will have 0 degree angle, 0 cos 0 will be 1. When we solve it, we'll get it 0.5 Weber. 0.5 Weber. Option is, we have option number 1. Option number 1 is our correct answer, right? This angle, I hope angle thing is clear to everyone. How we find out direction of area vector? Area vector is always perpendicular to the plane, and turn your fingers in the direction of current, thumb will give you direction of area vector. Magnetic field inward, area vector inward, and both are in same direction. So cos 0 is your 1. Let's move ahead. Yeah, so our question, let us see. It says a big circular coil of 1000 turns and average radius of 10 meter. Circular coil is there, turns are 1000 and average radius r is given as 10 meter. Fine. It is rotating about its horizontal diameter. It is rotating about its horizontal diameter at 2 radian per second. That means omega, the angular speed is given to us 2 radian per second. Fine. If the vertical component of Earth's magnetic field at that place B is 2 into 10 power minus 5 Tesla. So over here vertical component is 2 into 10 power minus 5 Tesla. Well and good. And the electrical resistance of the coil is 12.56 ohm. Resistance is 12.56. This is 12.56 ohm. Then the maximum induced current in the coil will be fine. Why is current getting induced in it? Current will get induced because your EMF will get induced. EMF will get induced because flux is changing. Why flux is changing? Over here magnetic field is there in this region 2 into 10 power minus 5 and this coil is rotating. If this coil rotates, what will happen? Phi, flux we write as BA cos theta, right? Magnetic field is constant. As such, the area for this one will be pi r square only. But the angle associated with between your magnetic field and area vector will be perpendicular to the plane. So this theta will continuously change because of the rotation of the circular loop, right? And therefore, due to this change in theta, your continuously EMF will get induced. So let us see. EMF induced, E is minus d phi by dt. EMF is minus d phi by dt, Faraday's law. Let us do it. Minus of, if we differentiate it, BA cos theta differentiation is your minus sine theta and minus minus will be plus sine theta into d theta by dt. I hope this is clear what I have done over here. I have differentiated this with respect to t. So BA is constant, cos theta differentiation minus sine theta and theta d theta by dt. D theta by dt. Theta is the angle between B and A. D theta by dt is your rate of change of angular displacement or angular position over here, which will basically give us omega. So this one I can write as E is equals to BA omega sine theta. This is equals to omega, BA omega sine theta, right? This is, we have got EMF. Current will be what? Current will be E by R. We want maximum current, so maximum current will be I max will be E max by R, because resistance is anyways constant only. It is given to us 12.56. E max, you see over here, E max, BA omega sine theta. What will be the maximum value? Maximum value will be when your sine theta is maximum. Sine theta maximum is 1. So we can write I max is equals to E max. E max is, we can put over here, E max is BA omega. So BA omega by R. Now we have to substitute the values. B is 2 into 10 power minus 5. Area for this, it will be pi r square, pi into 10 square into omega. Omega is given to us 2 divided by 12.56, right? When we'll solve this, your current will come, I max value will be 1 ampere, right? So this is the procedure, kind of a decent good question, and now please keep this in mind how we got this relation EMF by differentiating 5. In this case your theta was changing, right? So current maximum will be 1 ampere. Your answer is second option, right? Let's move ahead. Yeah, so our next question says, two conducting circular loops of radii r1 and r2 are placed in the same plane with their centers coinciding. Fine. So two circular coils r1 and r2, given r1 is greater than r2, the mutual inductance M between them will be directly proportional to. So one we will take it as primary coil, another will be secondary coil, and let's say we know the relation that phi is proportional to current, and your flux is directly proportional to the current flowing in the other one, and we can write phi is equals to M into I. We want to find out your M. What is M relation related with R1 and R2? So how we will do it? Let us say that I current is flowing through this outer coil. So if I current will flow through this outer coil, what will happen? It will produce magnetic field at the center. It will produce magnetic field. How much magnetic field it will produce? B will be mu naught I by 2 R1. right? Now, due to this magnetic field over here, due to this magnetic field, we can write down the flux associated with the inner coil. So, flux associated with inner coil can be written as phi is equals to BA cos theta. Magnetic field B, right now, just now we wrote it mu naught I by 2R1 into area for the inner coil, cross section area for this one will be your pi R2 square into cos theta, current is, magnetic field is inward, area vector inward, therefore theta will be 0, cos 0 will be 1. So phi can be written as mu naught I by 2R1 into pi R2 square. Now phi by I, that is flux by current, this constant, this is your actually M, mutual inductance, and how much it is coming, if you see carefully, it comes out mu naught pi R2 square by 2R1. Now you check it, what can we write? M is directly proportional to, or M over here we can write it R2 square by R1. R2 square by R1. This is what it is. Mutual inductance R2 square by R1. Which option it is? Not visible in my screen. R2 square by R1, that is option number D. D option is the correct answer. Let's move ahead. Yeah. Next, we have a theoretical question. It says, in which of the following devices the eddy current is not used? First, induction furnace, second, magnetic braking in the train, third, electromagnet, and fourth, electric heater. Now, out of all these four, this is a theoretical NCERT question. Out of four, the fourth option, that is electric heater works on your Joule's heating law. That means your I square RT on that, that is our relation, right? So, fourth is your correct answer. Yeah, next question. It says a 800 ton coil of effective area 0.05 meter square. Let's say, so coil will take it. Area is given to us 0.05 meter square. Number of turns are also given to us 800. Next it says is kept perpendicular to magnetic field 5 into 10 power minus 5 Tesla. So we can call it, if we have assumed the loop in XY plane, magnetic field perpendicular, so perpendicular magnetic field, we can take it as inward direction. How much it is? B value 5 into 10 power minus 5 Tesla. Okay. When the plane of the coil is rotated by 90 degree around any of its axes in 0.1 second, T is 0.1 second, the EMF induced in the coil is. So initially it is like this, right? What is the initial angle between your area vector and magnetic field? Because area vector will be inward, area vector is always perpendicular to the plane. So this is your plane, area vector will be inward, magnetic field is also inward. So initial angle, that is theta initial, is 0 degree. When you turn it by 90 degree, let's say that if you turn it by 90 degree, the plane will get like this. So now area vector will be coming this way, area vector will be x direction, magnetic field minus z, angle is 90. So finally your theta final will be 90 degree, right? This is what it will come. Now let us see. So EMF induced, what do we know? EMF is equals to minus delta phi by delta t, minus delta phi by delta t, which we can write as minus phi final minus phi initial by delta t. Phi initial, phi final, if we write it BA cos theta final minus BA cos theta initial divided by delta t. Because what is changing in your flux? In flux BA cos theta, which quantity is changing? Theta value, theta, that is angle between magnetic field and area vector, that theta will be changing when it will be turned by 90 degrees, and therefore we are writing over here BA is constant, theta is theta final and theta initial. Now over here if you will notice, theta final is 90, cos 90 will be 0, therefore this term becomes 0 automatically, and this will be minus minus plus, so our E value comes out BA cos theta initial is 0 divided by delta t. This is for one loop. This is for one loop we have written. How many turns are given to us? Over here 800 turns are given. So total EMF will be into 800. Let us solve it. I'll substitute all the values. E is equals to BA. B is 5 into 10 power minus 5 into A is 5 into 10 power minus 2 into 1 divided by 800 is also there, divided by time is 0.1 second, that is 1 into 10 power minus 1. When we'll solve it, this will come out to be 0.02 volt, right? This is 5 into 5, 25, 25 into 8, 200. Here it will be your, so 2 into 10 power 4, and this will be 2 into 10 power minus 7. Finally, when you will solve it, you will get it 0.02 volt, which is your option number 4. Fourth option is a correct answer. Yeah. The variation of EMF with time for 4 types of generators is shown in figure. Which among them can be called as AC voltage? AC voltage, what do we understand by AC voltage? Alternating current, that is the voltage which is providing alternating current. AC definition, by definition, AC means which changes its direction periodically. That means change in direction periodically. This is what is the definition for AC. Now, if you check all the 4 graphs that are given to you, in all the 4 graphs, all are changing their direction. For some part it is positive, EMF is positive, then negative, positive, negative. That implies A, B, C, D, all 4 are the correct answer, right? Option will be your B option will be a correct answer. Yeah. So the question we have is, it says a cycle wheel of radius 0.5 meters is rotated with an angular velocity, constant angular velocity of 10 radian per second. Okay. Radius is given to us as 0.5 meter and angular velocity omega is given to us as 10 radian per second. Fine. In a region of magnetic field 0.1 Tesla, which is perpendicular to the plane. So let's say this is your plane, magnetic field is B is 0.1 Tesla. Fine. The EMF generated between its center and the rim is. Now, first of all, this question is from your motional EMF. Over here, the wheel is rotating, motional EMF. What can we write the result? Result for motional EMF, it can be written as 1 by 2 B L square omega. I hope you know this. If you don't know it, keep this in mind. For motional EMF, we can write it half B L square omega. So E is equals to, let us substitute 1 by 2 B, that is 0.1, 1 by 10 into L square. L will be equals to, this is equivalent to a rod whose length is equivalent to your radius of this rim, which is 0.5. So 0.5 1 by 2 whole square into omega is 10. Let us solve it. E is equals to 1 by 2 into 1 by 10. This 10 will cancel out. We'll get over here 1 by 4. So E is equals to 1 by 8. Now 1 by 8 is our answer. They have given in terms of decimal. We'll change it. It will come out to be 0.125 volt, right? Let's move ahead. Yeah. Question we have is, the magnetic potential energy stored in a certain inductor is 25 millijoule. So energy is 25 millijoule. Okay. When the current in the inductor is 60 milliampere, I is 60 milliampere, then the inductor is of inductance. So inductance, they are asking us 4 options are given. First of all, what is energy? Already we saw in the first question itself. So energy for an inductor, stored energy is half Li square. Energy is given to us 25 millijoule. 25 millijoule we'll have to convert into joule. 25 into 10 power minus 3 is equals to 1 by 2 into L into I square. 60 milliampere. So again this will be 60 into 10 power minus 3 whole square. Right, we can solve it. 25 to is 50, so 50 into 10 power minus 3 divided by 60 square, 3600 into 10 power minus 6. Solve this value, right? L value will come out to be your 13.89 Henry, right? When we'll simplify this, our answer will come out to be 13.89 Henry, right? This is our relation for energy. Let's move ahead. Yeah. So the next question that we have is, it says a long question. I have drawn the figure already. Let us see. A long solenoid of diameter 0.1 meter has 2 into 10 power 4 turns per meter. Solenoid is there. Okay. Diameter is 0.1. Number of turns per unit length is 2 into 10 power 4. Okay. At the center of solenoid, a coil of 100 turns and radius 0.01 meter is placed with its axis coinciding with the solenoid axis. As you can see, this coil is there, number of turns 100, radius is 0.01 meter. Next, it says the current in the solenoid reduces at a constant rate to 0 ampere for 4 ampere from 4 ampere in 0.05 second. That means the current, this I, the current I flowing in the solenoid, it goes from 4 ampere to 0 ampere in 0.05 second. Okay, if the resistance of the coil is 10 pi square, resistance of this coil is 10 pi square, the total charge flowing through the coil during this time is. Now, why charge will be flowing through this one? Basically, current is flowing through this, current is changing from 4 to 0. If current is changing, as we know that current carrying solenoid will produce magnetic field. If current is changing, magnetic field will change. First of all, how much is our magnetic field produced by solenoid? B is equals to mu naught Ni, right? And as current will change, the magnetic field that is over here in a solenoid, your uniform magnetic field is there. Uniform mu naught Ni, right? But current is changing, so obviously with time your magnetic field also changes. Okay. Now, if magnetic field changes, the flux linked with this coil, also changes. What is our flux relation? Flux is BA cos theta. If magnetic field changes, flux also changes. If flux changes, your EMF will get induced, current will come, and current will be due to your flow of charge. What is our relation? Q is given as minus delta phi by resistance. If you know the result, well and good. If you don't know the result, please keep this result in mind. Otherwise, in exam, deriving this result will be a very big deal. Means it's a lengthy thing. We will get stuck to derive this result. It comes from Faraday's law only, but this is our result. This is your charge. Charge is equals to minus delta phi by R. Whenever your current will get induced, the charge flowing will be minus delta phi by R. Please keep this result in mind. Now, minus delta phi by R. Let us substitute. Q is equals to minus delta phi. That means phi final minus phi initial divided by resistance. As you can see that finally it is becoming 0 ampere. Finally, if current is 0, magnetic field will also be 0. If magnetic field is 0, phi will be 0. Because flux is what? BA cos theta. If magnetic current 0, magnetic field 0, magnetic field 0, flux 0. Flux 0, that means phi final is 0, minus minus plus. So our Q value finally comes out phi by R. That means the charge that will flow will be equals to flux by resistance. Let us substitute. Flux we know is BA cos theta divided by R. Acha, one thing that we need to be careful with, we have to write flux associated with this due to the magnetic field which is being produced by the solenoid. We need to be careful that over here total 100 turns are given. So this we have to do into 100, right? BA cos theta is due to 1 turn. BA cos theta into 100 due to total 100 turns. Let's substitute B. B is mu naught Ni, magnetic field due to solenoid. Area for this one, radius is given to us 0.01. So area can be written as pi into R square. If we do over here, pi into R square. R is 1 into 10 power minus 2. So 10 power minus 2 square will be 10 power minus 4 into, so this is BA cos theta. Theta is magnetic field, area vector. Both are in same direction. Theta will be 0, cos 0 is 1 into 10 power 2 divided by resistance. Resistance is how much? 10 pi square. Right? Let's substitute. What are we getting? This is your 4 pi into 10 power minus 7. N is 2 into 10 power minus 4. Sorry, 2 into 10 power 4 into current. Current, initially the current was your 4 ampere. I hope you people are following. Into pi into 10 power minus 4 into 10 power 2 divided by 10 pi square. Let's see what all we have. Pi and denominator also pi square is there. It cancels out. 10 power 4, 10 power minus 4 cancels out. Next we have, this is 4 to 8, 8 4 is 32. So we are left with, this will become 10 power minus, this is 110 cancels out. So we have your 4 to 8, 8 4 is 32, 32 into 10 power minus 6 coulomb. 32 into 10 power minus 6 coulomb is our answer. Check all the options. All the options, when you will check it, it is given in microcoulomb. We can convert it, not a big issue. We know 1 microcoulomb is 10 power minus 6, so this will come out 32 microcoulomb, right? Option number D, option number 4. Option number 4 is our correct answer. I hope you got it. Please keep this result in mind, right? Good result. Okay, then let us move ahead. Last question. So over here we have reached to 2017. Last question. Let us solve it. Yeah. So we have reached to our last question. It says a long solenoid has 1000 turns. When a current of 4 ampere flows through it, the magnetic flux linked with each turn of the solenoid is 4 into 10 power minus 3 Weber. So phi is 4 into 10 power minus 3 Weber. For one turn they have given how many turns are there total? 1000 turns are there. Okay, this is capital N. Okay, next it says the self inductance of the solenoid is, current is also given, I is 4 ampere. What is our relation of self inductance? We know phi is directly proportional to current I and phi is equals to L into I. L is our self inductance. So what can we write? L is equals to phi by I. Over here this flux which is given, this is for one loop, right? Over here total turns are 1000, so we can write down 4 into 10 power minus 3 into 10 power 3 divided by current. Current is 4 ampere. As you can see, cancels out everything. Answer is 1 H. 1 H. Inductance unit is Henry, so our answer will be 1 Henry. You check your option. Option is B option, right? I hope you found the video helpful, right? We have solved all the questions from 2023 to 2016. Do consider to press the like button and subscribe to our channel. Thank you very much. Bye bye.